we'll be moving to differential equation of natural logarithm. After solving these examples, I hope you will get a better understanding of how to solve natural logarithm, how to differentiate natural logarithm. So let's get started. Y equals to n x squared minus 5x plus 1. So when you want to differentiate this type of differentiation, which is natural logarithm, all you have to do is differentiate this equation inside this bracket and divide it with it. First, let's take it. dy dx will be equals to, when you differentiate this, you have that 2x, subtract 1 will be 2x minus 5x, right? Then you divide it with what is inside the bracket, x squared minus 5x plus 1. So this is the answer. And number 2 says, so f of x is equals to n bracket x raised to power x2 minus x plus 1 bracket close. Remember what I said before? I said you will differentiate the inside and divide it with what is inside. So to differentiate it, we say dy dx is equals to, when you differentiate it, remember we did exponential differentiation, so all you have to do is just differentiate to s and multiply it with the constants or the coefficient. So when you differentiate to s, you have 2, repeat it, 2x minus, when you differentiate x, you have 1, right? When you differentiate constant is 0, so you divide it with what is inside, e raised to power x minus x plus 1. So this is the answer for number 2. So let's move to number 3. Number 3 says y equals to n bracket 3x plus 2. So still the same rule. You differentiate the inside. You have 3 divided by, right? 3 divided by 3x plus 2. Because when you differentiate 3x, it will give you 3. So this is the answer for number 3. Number 4 says f of x equals to nx in bracket x squared plus 1. So you differentiate it, 2x plus 1 all over x squared plus 1. So 5 says f of x is equals to n bracket sine x. This one involves trigonometric functions, so you have to pay close attention. So the y dx is still the same rule anyway, is equals to, when you differentiate sine x, it will give you cos x, then you divide it with sine x, right? So but in trigonometric rule, when cos x is divided by sine x, it will give you minus cos x minus cos x. So this is the answer. So we have number 6. Number 6 is y is equals to n bracket x squared minus 2x plus 1 raised to power 8, close bracket, raised to power 8. So it's still the same, but there is a logarithm rule that says that log x raised to power a is equals to a log x. It's still the same thing in natural logarithm, like in n says in x raised to power a is also the same thing as a in x, because we'll be applying the rules here. So what you have to do now to change it, we say that 8 n bracket x square, to remove the power so that you'll be able to differentiate it, minus 2x plus 1 close bracket. I hope you understand what I'm doing. So now you will differentiate the inside. When you differentiate, you have 2x, so I say the y dx is equals to 2x minus 2, right? So remember you have constants outside here, so we divide it with what is inside, x squared minus 2x plus 1. So you open the bracket. When you open the bracket, you have that 16x minus 16x minus 16 divided by x2 x plus 1. So you can still factorize 16 out. You have 16 bracket x minus 1 all over x squared over x squared minus 2x plus 1. So this is for number 6. So 7, we have n of square root of x. So it's still the same natural logarithm. Still the same natural logarithm. So yeah, you have to change it to indices n x, right? So now the same rules still apply. The same rules of n that state that x equals a is also a in x. So we apply the rule here. So you have that half of x is equals to half of x is equals to in x. Sorry, in x. Hope you understand what I did. So when you differentiate x, you have 1 and divide it with the x. So when you multiply it, you have that 1 over 2x. So this is the answer.